Anthropic, a world-renowned AI firm founded by former researchers from OpenAI, is ushering in a new era of AI development with their newly unveiled chatbot, Claude 2, which is the latest large language model intended to compete with and exceed other widely recognized AI models, such as GPT-4, Google Bard, and Bing by over 30 times, with its parameters reportedly blowing away competitors. Established in 2021 and fueled with a robust investment of $1.5 billion, Anthropic represents a potent challenge to OpenAI. And while OpenAI boasts of a head start with its popular large language model and the backing of a billion-dollar investment from Microsoft, Anthropic's first AI model, Claude, has demonstrated notable resilience in preliminary benchmarks. But what makes Claude 2 over 30 times better than GPT-4? Incredibly, Anthropic is now raising the stakes with Claude 2, an AI model endowed with multiple enhancements. In particular, this advanced chatbot boasts improved conversational abilities, more articulate explanations of its thought processes, a safer output mechanism, a longer memory, and bolstered programming, mathematical and cognitive skills. And while these are certainly impressive features, there is one that sets Claude 2 apart in the world of AI. One of Claude 2's defining features is its capacity for generating extensive content, from documents, memos, and letters to technical documentation, and even full-length books. Claude 2 also stands out for its ability to process up to 75,000 words, or 100,000 tokens, at a time. This capability significantly surpasses ChatGPT's standard limit of 3,000 words, allowing Claude 2 to consider more context, thus improving the quality of responses and diversifying the tasks it can undertake. So, how does Claude 2 perform when put to the test? Claude 2's performance is nothing short of extraordinary. On the multiple-choice segment of the American bar exam, Claude 2 attained an impressive score of 76.5%, keeping pace with GPT-4. In contrast, ChatGPT managed an average score of around 50%. On the Codex Human Evil Python programming test, Claude 2 achieved a remarkable score of 71.2%, and an even more impressive 88% on GSN 8K elementary school math problems. But how does this translate into practical applications? With Anthropic scheduling a gradual and iterative release of additional capabilities that will compete with and exceed the likes of various AI plugins already available for GPT-4, Claude 2 is also being developed with an explicit emphasis on safety. Furthermore, unlike OpenAI, Anthropic utilizes an AI-based feedback mechanism to optimize the model, bypassing the need for human intervention. It also sets a baseline of guidelines in the form of a constitution. And yet, this meticulous attention to safety does not compromise its real-world application. In fact, Claude 2 has also shown a considerable improvement in red team testing scenarios, where it is intentionally pushed to make mistakes. According to Anthropic, Claude 2 significantly outperformed its predecessor, offering a more satisfying user experience. However, Anthropic acknowledges that while Claude 2 shows promise, it is not entirely free of inaccuracies or misinformation. The company concedes that they still have a number of challenges to overcome. But what does this mean for the industry as a whole? Claude 2 has already been embraced by thousands of companies utilizing the Claude 2 API, including notable partners such as Jasper, a generative AI platform for marketing copy, and SourceGraph, a code AI platform. These organizations leverage Claude's superior reasoning abilities and larger context windows to aid developers in writing, fixing, and maintaining code. In a strategic move, Anthropic is offering the Claude 2 API to business customers at the same price as its predecessor, Claude 1.3. Additionally, the web chatbot is now available as a free beta in the US and the UK. As we watch Anthropic's foray into advancing AI capabilities unfold, one thing is clear: the landscape of artificial intelligence is about to change dramatically, and Claude 2 is leading the charge. Stay tuned for more updates on this exciting development in the world of AI. Meanwhile, Microsoft has just unveiled LongNet, a transformative intelligence technology that's poised to reshape the way we understand and leverage web-scale AI in large language models. In fact, this radical development could even empower transformer models to process extensive sections of the internet simultaneously, making ChatGPT's 4,000 tokens seem minuscule by comparison. as LongNet promises a staggering capacity of 1 billion tokens. So what does LongNet mean for the future of AI? Importantly, transformer models' sequence length significantly impacts their performance in both training and deployment. Expanding sequence lengths provide a larger context window, allowing a language model to process and generate more text or a vision transformer to capture more detailed information from an image. However, one significant challenge lies in the fact that the sequence length and the required computational power share a quadratic relationship in the standard transformer architecture, leading to a rapid increase in computational demand. But here is where LongNet changes the game. LongNet's incredible capacity enables it to process 250,000 times more tokens than ChatGPT, equivalent to roughly 750 million words or 2 million pages. Compared to commercially available models like Anthropic's Claude, which can handle approximately 100,000 tokens, LongNet represents a phenomenal leap forward. But how does LongNet achieve this extraordinary feat? Microsoft's team has adapted an attention mechanism, termed dilated attention, to achieve this exponential increase in sequence length. The dilated attention mechanism operates such that the allocation of attention exponentially diminishes as the distance between tokens increases. As a result, the network scrutinizes the relationships between nearby tokens as closely as a standard attention mechanism, while applying broader attention patterns to tokens that are more distant. In a test case, Microsoft's team utilized LongNet to train a speech generation model with up to 32,000 tokens, contrasting its performance with classical transformer-based approaches. According to the team, LongNet successfully demonstrated known scaling laws of classical transform models. However, the future possibilities for LongNet are even more exciting. Furthermore, LongNet's capacity to process web-sized datasets could significantly impact AI's interaction with people and the world at large. A larger context window, which encompasses more complex causality and reasoning paths, could improve models' generalizability. Additionally, LongNet could potentially revolutionize many-shot learning by utilizing its extremely long context to alleviate models' catastrophic forgetting, a common challenge in AI. However, it is essential to note that LongNet is, for now, a proof of concept. The team has not yet provided comprehensive comparisons with modern language models like GPT-432K or metrics such as accuracy or human evaluations. Hence, whether these enormous sequence lengths will offer real advantages in practice remains to be seen in subsequent research. The Microsoft team has high hopes for LongNet's future applications, including multimodal large language models or genomic data modeling. As we watch LongNet's journey unfold, we can only imagine the incredible possibilities that this could mean for the future of AI. The world of AI continues to expand, and with developments like LongNet, we're just scratching the surface of what's possible.